Well, the next part of our meetup is the event itself. We have two exciting speakers for you today. This one's not right. Oh, that's right. I removed the slides because we don't have the pictures. But that said, and thanks, Ravi, for sharing your LinkedIn profile there. So today we have my good friend, Joe Eames. I've known him for a few years now. He's founded this meetup, which is a fun fact. It used to be the Angular Utah meetup. It was an in-person meetup, and the best part was they had pizza every single time. And then we would just
STG.
Yep, STG used to sponsor that pizza. What was the name of the company? Lucid used to host us in their very own building. It was fantastic and good times, and we might restore that again now that in-person events are starting to come back. But we love serving the community around this time zone, so thank you all for coming. Give it up for Joe Eames. He not only has run ng-conf for many years, and helped start it. He also continues to help run XLTS and with Aaron, and he is a GDE for Angular, and he ran Thinkster and so many other things. So we have a lot to learn from Joe. Not only that, he gives master classes in testing. So prepare yourself for this one.
Thanks, Eric. All right, I'm excited to talk today. The title of my talk is a concrete reason to use abstract types. So we're talking about TypeScript. In fact, what we're going to do today is going to be completely Angular agnostic, no Angular involved whatsoever. So what I want to do is I want to try to tackle the idea of abstract types in a way that hopefully everybody who has some lack of familiarity with what abstract types are in TypeScript, why to use them and when to use them, that you might get out of something out of this. So it's also very hands-on. We're going to have two coding problems to do during this talk. This is the first time I've presented the subject, so I have no idea how long this is going to take. It's going to take anywhere between 20 minutes and an hour. I have no idea. We'll find out when I get to it. Hopefully not anywhere near the hour mark. But there's going to be a couple of coding challenges to do, and they should be very simple. So even if you're not very comfortable with a lot of TypeScript and JavaScript, it should be very accomplishable for you today. Now, I want to start off by talking about what got me really into programming. I was something like 16 or 17, and I took a class on computer science, and they taught Pascal at the time. And at the time, I was heavily playing Dungeons and Dragons with my friends. And I realized that I could code up a program that would assist me as a dungeon master and help me do things rather than it would do things faster for me. So that's why I started coding. And because I was driven to do this thing, I was constantly learning more. And I definitely credit the fact that I got into programming to this drive that by itself was external to programming, which was I wanted to be able to do these things, and programming helped me do these things. So I always like to relate a need or a tool in programming to a potential need. So I'm going to start off by talking about a need by showing one of my hobbies. So I'm going to share my screen here. And let's see. We're going to share this screen here. There we go. So this is one of my hobbies, which is painting. John and I were chatting about this earlier. John doesn't like the part of painting when it comes to miniatures, but I actually like painting. I find it to be very relaxing until my hand gets cramped. So this is something that I painted. I picked this because it's a little thematic for this time of year here. This is a couple of miniatures that I like painting miniatures. I have no capability of painting anything on a canvas, but I like painting miniatures. So here's a couple of miniatures that I painted. They kind of go in a set, little creepy. Here's another miniature that I painted. This is a Star-Lord, of course. Everybody recognizes that. But mostly what I really like to paint is these miniatures from a game that I play called Star Wars Legion. So here's one of the miniatures that I painted from Star Wars Legion. Here's another one that I painted. This one was a little early, but I gave these ones a theme as well. And then here's some others that I painted, and you can see I really got into the bases here and did some fun things with their bases. But I really enjoy painting miniatures, and this game, the Star Wars game, is something that I enjoy playing with one of my kids. So the thing about this Star Wars game is that it involves dice. I'm going to stop sharing for a moment here, and I'm going to talk about dice. So in this game, you roll dice, and the dice determines what happens in the game. So if, for example, I took my Darth Maul figure and I attacked the Tauntauns with Darth Maul, I would roll some dice as an attacker. And then the defender would also roll some dice based on the dice that I rolled as an attacker. They would also roll some dice. So I'm going to show you some examples of some of the dice that are used in the game. So if I'm an attacker, I roll one of these, and I'm just going to kind of hold this up so people can see. This is an 8-sided dice or die. This is an 8-sided die. You can see it has a variety of symbols on it, and I'll kind of explain these symbols. So this little star means that if that face is up when I roll it, then I've gotten a hit. So Darth Maul is going to potentially do a point of damage. And then you can see that it's got a blank side to it. So out of the 8 sides on this red dice, one of them is blank, and that means that he missed if that die comes up. And then there's also this star that's hollow. There's one of those on this 8-sided die. That's a crit. And the crit just means it's harder for them to try to get rid of the damage that's potentially coming in with their defensive dice. And then finally, there's this one with the really weird symbol, and I want you to kind of pay special attention to this. This is the surge die, or surge face. And so I'll talk about the surge here in a minute. This is a black, there's 3 colors if you're an attacker. There was red, there's black, and then there's white, right? So they kind of rank in order. If you're a really powerful character like Darth Maul, you probably roll lots of red dice. And if you notice, there was only one blank face on that red die. All the rest had either the regular hit or the crit or the surge. Same thing with the black die. It's a little bit different. The black die has 3 blank faces. So there's 1, 2, 3 blank faces. And then it has same thing, 1 crit and one of those surge faces there. And then the other 3 are hits on that die. And then the white die is the weakest, right? So on the white die, there's 1, 2, 3, 4, 5 blanks faces. So 2 here, and as I scroll around, you can see there's 3, 4, 5 blanks. It has 1 hit, 1 crit, and 1 surge face. So the white is by far the weakest. That's what stormtroopers roll, is white die. That was a joke for everybody. But it's real in the game. So the stormtroopers are the worst at landing hits, and Darth Maul is the best, and he rolled red. And then people in between, there's a variety of dice, and every type of character might have a different profile for what kind of dice they roll. And I became kind of interested in simulating. Well, what would happen if these were the types of die that a particular attacker rolls? Now, I mentioned that if that's what the attacker rolls, the defender also rolls dice, but the defender rolls a 6-sided die. So it looks, it's this normal cube shape. And the defender only has 2 colors of die, white and red. So if you're a really tough, strong person or character in the game has a good defense, you're going to roll a red die. So people with good armor, like stormtroopers, they roll red die. And people with weak armor, like say the rebel troopers, they would roll white die. And the difference again is it's similar to it. There's no black dice on this, but on the red die, there are different faces. So there's a blank on that side, a blank on that side. So there's 2 blanks. There's a little triangle. The triangle means you block. And there's another triangle. There's another triangle. So there's 3 triangles. And then there's this face again. This is the surge, but this is the surge for defense. So again, it's a special one. I'm going to come back to this surge. Now the white die I'll show you is much weaker. So the white die only has 1 block face and 1 surge face. So if the attacker rolls, maybe he rolls 3 hits, then as a defender, I roll my die and I roll 3 of them, and I hope that I try to block all those, and the little triangle face comes up and blocks them. And then I don't take any damage. And that's kind of how the game is played. And it's not really important to really understand all of this, but I want to go back to these surge. So again, the attacker die has the surge face on it, right? And the defender die has the surge face on it. And what happens is certain characters have a special ability that if the surge comes up, they do what's called surging to. So if you're an attacker, you might surge to hit, in which case if the surge die faces up, you actually change that face to a hit. And if you're a defender and you surge to defend, then if you're a defender and you roll the defense die and the surge face comes up, you get to change that to a block. So it's valuable to be able to surge to something. It's valuable in the game, but it really creates these kind of interesting probabilities in the game as some characters use this color of dice, but they also surge to hit or they surge to defend. So as I was trying to write some kind of a program to model this, I came across an interesting thing that happens frequently in programming. And it caused me to end up utilizing an abstract type in TypeScript. So kind of want to walk through the steps that I took to get there. Now, I'm going to talk for a minute about abstract types and concrete types. And I'm not going to define each of those yet, but instead I want to do a programming problem here. So I'm going to open up, or I'm going to put into chat a programming problem, a link to a StackBlitz project that you can fork. And I want you to work through this problem as best you can. I'm going to give you about 5 minutes. So it says I'm in Mountain Time. It's 6:32 my time. So we're going to go until 6:38, which is 5 minutes plus some change. And it should kind of be somewhat self-explanatory. Let me, I'm going to share out my screen again and sort of walk through this. So you can go ahead and start if you feel like it's obvious, but I'm going to kind of at least show you the code that I'm talking about and kind of explain this. So we're writing a very basic simulator. And we're going to have 2 different dice. One die needs to be offense and one die needs to be defense. And I kind of showed in here that a die has 2 properties. It has a color, and then once you roll it, it has a value. So those are the 2 things that are important about a die: is what color is it, and what's the value? Is it a hit, a crit, a block? And so I kind of outlined that here. The colors are red, black, and white if you're on offense, and for defense they have red or white. So the total set of colors is red, black, and white. And the values, here's the values if you're offensive, and then there's the values if you're defensive, but the total set of them are blank, surge, hit, crit, and block. And so I want you to create 2 die. The first die should be a red offensive die, and the value should be unset until it has its roll function called on it. Same thing, a white die should be a white defensive, or the second die should be a white defensive die whose value is unset. So we want 2 properties. We want the color and the value, right? And then they need to have some method to roll themselves, a roll method. So I want you to try to code this up and just be as simple as possible. And I just want you to work through this. So we'll go an extra minute. We'll go to 6:39 or 39 after the hour, whatever it is in your time. But give it a few minutes and try to just code this up very simply and kind of make this work. I've already coded up some of this, but make the model. So what you're going to be creating here is the model. So I'll go for like 5 minutes, and then I'll kick back in and we'll talk through this and through a solution of this.
Hey, Joe, there's someone in chat that would like for you to zoom in a little bit so that they can read a little better.
Yeah, thanks for the reminder. Sorry for.
No problem.
Yeah. And if you pull up the link that I put into chat, you'll see the same code. But when I code, we'll want to be able to read my code. Let me know if that's not zoomed in enough for people to see. And you'll need a fork. You click the fork button. If you haven't used StackBlitz before, you'll want to click the fork button. And I'll just remind you, read all the directions, all the little comments, read them all, because there's some important stuff so that you understand the problem here and how abstract types will ultimately solve this. All right, we're at 6:39. Now, if you're still coding this, please feel free to go ahead. I'm just going to start coding up my solution, and I'm going to talk through it. Hopefully, I don't distract you. But I'm going to start coding through how, a very simple, naive implementation of this. So I want to be as simple as possible and code this up. I need 2 die. One's going to be an offensive red die, and the other one's going to be a defensive white die. So I'm just going to comment out this let die1, let die2. I'll say let die1 equal, and I'm just going to create an object, right? This is TypeScript is JavaScript, just a superset. So I could just create an object like this, and I'm going to give it its properties. So I'm going to have a value, and I'm going to set that to undefined. For now, it's going to start out undefined, but we'll fix that later. And I got the column here. Okay, and then we need a color. So this first die, that's an offensive red die. So I'm just going to put red in a string. Simple. And then it has to have a roll method. And so for the roll method, I said in here that the function should always set the value to surge. So I'm going to say this dot value surge. Oh, I can't do this because I don't. Let's see. What did I do wrong? Object is possibly undefined. Awesome. So I'm doing this wrong. Sorry, give me a second here. I need to do this as just a function, right? And then we get this dot value search. Okay. So there's my die1. Let's do die2. Value again, undefined. Color is white. And then the same function. I did double quotes this time, doesn't matter. All right, so I got my 2 die here. Now I need a handle to surge them to offense or defense. I know how to log out their value. Console.log die.value. If I look at the console, we'll see that it's still surge because I haven't handled the surge. It's supposed to, these are supposed to surge. The one offense die should surge to a hit. The defense die should surge to a block. So they surge to different values. There's a bunch of ways that I could handle this, but notice that I've got already these functions handle offensive surge and handle defensive surge. So it makes sense that I would call one or the other of these. So I just need to know which one to call, if, and I need some kind of an if thing. So maybe I'll go back up here and give it a type. Offense. And then I'll go up here and give this one a type. Defense. And now if die.type offense, then we're going to call handle surge and pass in that die. Else handle surge and pass the die. And now if we look at our results, we got hit and block over on the right hand side. So this now works. And I've got 2 different die and they're both surging correctly, right? But there's a few problems with what I've done here so far. So let's kind of talk about some of the problems. One of the problems is I've just created 2 different objects. And those objects are what they are. And if I come down over here and I type in die1 dot, I can see what the properties on die1 is, right? Same thing, die2 dot, I can see what the properties are. But once I'm inside of my algorithm, and I call die dot, I don't get any IntelliSense. It doesn't know what the die is. And that's one of the pieces of beauty of TypeScript is we can have types, and the types can constrain us so that if I accidentally put in die dot role and misspell it, I don't get an error. If I don't check it and accidentally send this to production, I don't get errors in production because I know I would get IntelliSense if I actually had a type and I knew that it had a role function and not a role function. Or in a bigger, more complex system, I don't necessarily have the die object themselves just a few lines up that I can look at them and visually see what they are. Again, some of the beauty of TypeScript and the fact that we can have types and classes, right? So obviously that's a major problem, is that we don't have types. Another problem, we don't have IntelliSense, so we don't have types, and that gives us like a runtime checking. We don't have IntelliSense to just help guide us along. And again, a problem with not having types. Another thing that's kind of interesting about this is we have to put in this ugly if. And if you notice, you might look at this and say, well, hey, we got the role function on each one. Why don't we just put the handle surge function on each one? And we could do that. And that way we could get rid of this if, and we could just call die.handle surge themselves. So we could get rid of that, and we could just call die.handle surge. And that way we don't have the if here. We have a handle surge on this one, which would surge to defense, and a handle surge on the other one, which would surge to offense. But there's a problem in that solution as well. And that is that as we add more and more functions to our classes, they start getting really huge, or in this case, our objects, they start getting really huge and they start doing lots of things. And suddenly we've got these classes or these objects that might have hundreds, if not thousands of lines in them. And we don't want that. We don't want to bloat our objects too much, right? So it's good to be able to have functions elsewhere that operate on our objects. So another thing that's interesting is you notice that this handle surge, these are pretty simple methods, right? But imagine these were a lot more complex methods, but they were very similar to each other. And that can happen. And maybe we'll talk in a second about a scenario where those happen. So there's a lot of problems with what's going on here. I've got these two functions that are very similar to each other, but slightly different, just different in what they go to. And you might have implemented something where maybe you might have looked at this and said, this is less effective. I'm going to pass in what they should surge to as an example so that I can use one algorithm instead of two. And as that algorithm grows, right, you only have to maintain one algorithm and fix bugs in one function. So a lot of problems with this implementation here. It's definitely not very optimal. And it certainly doesn't take advantage of TypeScript and its types. So depending on how you did this, if you implemented classes yourself, that's awesome. But we're going to redo this, and we're going to redo this with types. So I'm going to give you a new problem. And in this one, I've coded this out a little bit more. So I'm going to put in the link another TypeScript project, or Stack Blitz project. And this one's a little bit different. Zoom in a little bit here. Is that good enough for people to see? All right, yeah. So now we're going to implement this with classes. And I've done a little bit of extra work. I've added in enums. And if you haven't encountered enums in TypeScript, they're really awesome because they're a little bit like classes, but they're a discrete set of values. So rather than using strings, and you saw I was using strings in the last implementation, they're a lot nicer than strings because you can say like var a equals die value dot, and then it gives you your options. So blank, so for example, I can have now a blank. So it can have a class or an object. I can say a dot value, value is die value dot blank, for example. And I can restrict this to the set of values that work, whereas a string is technically an unlimited number of values, but I can restrict this to the set of values that actually work. So I've got enums for die value and for die color. And what I want you to do, so read through this, what I want you to do is use classes. If you used classes in your last one, come and maybe implement this again. And again, the classes need to have two properties, a value and a color. That's very important on the die is what's the value and what color is it? And then again, I've reiterated what the colors are and the values are. And then the first die should be a red offensive die whose value is unset until roll is called. The second die should be a white offensive die whose value is unset until you call roll. They should have a method called roll. And just set the roll method to always set the value to surge. And in a real implementation, we generate random values, but in this case, we want it to be surge because later on in our function, we want to handle the surge. Now notice here, I've limited it down to one surge function, just handle surge. And I want you to try to pass the die in here and handle surging to the value inside of just one method. And I've sort of written a little bit of the skeleton for you here. So we'll go again for 5 more minutes. We'll go till 54 after the hour and go ahead and code this up. And then I'll show my implementation. And you'll have to fork as well, because you're in fork before you start coding. Okay, it's 54 after. I'm going to go ahead and start kind of like coding up my my solution here. So again, this is about using classes instead of using objects. So I'm going to create some classes here. And what I want to do is try to keep it as simple as possible. So I'm going to create a class called die. And that could sound a little mean if we weren't in the context of rolling dice. So I got my die class and I need a couple of, I know I need a couple of properties. It needs to have a value and I can give this a type now. Give it a type of die value and I can give it a color, a type of die color. And then finally I can give it a roll method. And inside the roll method, this dot value equals die value dot surge. So once I have the die class, I can say new die. And then this first one is an offensive die with a color of red. So die one dot color equals die color dot red. Now, I'll just pause for a second. This isn't necessarily the point of this discussion here, but this would be much better implemented in a constructor, because what we don't want is to be able to create a die that has some kind of an invalid state. So an unrolled die would be okay, right? But if a die has to have a color all the time, then it would be better to put this in a constructor. And so I like to put my constructors after my properties. And this would be color. Dot color equals color. Right. And then I would just pass a die color dot red. Yeah, that's much better implementation. And then the other one is a new die with a die color of white. All right, much better looking. So now we got handle dice that rolls and it goes and handles surge, but we're not changing the value in here. And if we look at our console, we can see that the values are surge. We'll just make this run again. They're both set to surge. We need them to actually surge. One needs to go to a hit and the other one needs to go to a block, right? Because one of them is an offensive die and one of them is a defensive die. But we didn't really add in that description. So maybe again, let's use a Boolean for offensive. Okay, and then we could pass that in. And we should probably just do this, use the shorthand, right? So we don't have to put them there. Only color reference, and now we don't have to set that. And now we give it a red, and this is true. It is an offensive, right? This one is false. It is a defensive one, right? So now in our surge, we could just say if die dot, what was the name of that property I just gave it?
Offensive.
Oh yeah, offensive. Thank you. I can look up right now, right? And I can see that it's offensive, but in a real application, I don't have my type adjacent to where I'm manipulating it, right? That's the value of beauty of types. And notice I hit period and I don't get my IntelliSense. I want my IntelliSense, right? So let's give this a type, right? And now that we have that, we could do die dot offensive. If it's offensive, right? And not the other kind of offensive. We've got die and we got offensive. Boy, we're a lot of negative words going on in here. Die.value is equal to die value dot hit, else value equals die value dot block. Oops, I spelled capitalized. Okay. Well, I've got my type here, but notice I also want my type in here as well. So let's go ahead and give this a type. This is an array of die, right? And so now that we go through each die, we could do die dot, and we get our types, right? This is really nice, but what I do have that's kind of weird is this sort of like offensive Boolean, right? The minute that I realize that role needs to be different, if it's an offensive die or a defensive die, then what am I going to do? Let's say that for offensive die, randomly, when we roll the die, we know that we have a different profile. Offensive die have 8 possible outcomes. Defensive die have 6. So I've immediately got a problem in that this single class die doesn't actually work for me, because these two, the offensive die and the defensive die, they have to have different implementations of role. Now I don't need it right here yet, but if I actually implemented this role algorithm to randomly generate a value, it has to generate one of 8 values if it's an offensive die, and one of 6 values if it's a defensive die. And then again, is it a defensive red die or a defensive white die? It's going to have different values within that. So I know already that I do need 2 classes. So I'm going to fix this and create an offensive die class and a defensive die class. Oops. All right. Now, ultimately, these are very similar, except for we no longer need to take this in as a value, the offensive, because the type tells me what value it is, right? Now, this first one is an offensive die, and the second one is a defensive die. We no longer need to tell them that they are offensive or defensive. And I immediately have a problem, right? I want to have 2 classes because I want their implementations to vary. Offensive dice are different than defensive dice. We know that. We know that the roll method has got to be different. I've just hard-coded it to go to Surge, but ultimately these have to have different implementations. So I need different roll methods. Maybe I should extract roll out of the class itself. That's one option. I could extract the roll method out and make that somebody else's responsibility. But even if I did that, what happens with the next piece of functionality that belongs to the die, and they're different if you're offensive versus defensive? Notice that when I go back to my real world objects, this little 8-sided die and this little 6-sided die, these things have a lot of similarities, but they do have some differences. So sometimes I want them to be very discrete in my programming. And sometimes I want them to be different in my programming. I need them to have sometimes different implementations and sometimes similar implementations. And this problem happens all the time in programming, that we have things that are similar, yet occasionally different. And this is what we've been doing so far, is what's called modeling. We've been dealing with the model, how we structure or how we model the data and the functionality of our application. We've been dealing with this and working through this. And we've discovered that we have a need to have separate classes, but we want to sometimes treat them the same. This algorithm, this handle dice algorithm, is the same whether they're offensive or they're defensive dice. just handle surge needs to be a little different. And we talked about the fact that we could put the surge method inside of the class, right? Go back up here and add in handle surge. But that isn't a universal solution in all problems, because in a real application, this model would suddenly bloat up to hundreds of lines of code as we added in every possible piece of functionality. And furthermore, if we did do that, handle surge has some commonalities in it. So I want to talk about a specific implementation of handle surge. In the game, there are these little things called tokens. So I'm going to show you, I'm going to show you a token. This is a surge token. And I can have a surge token and it can belong to like my unit. So Darth Maul might have a surge token. And when Darth Maul rolls his red dice, if he rolls 5 red dice and 2 of them come up with surge values, I can spend one of the surge tokens to take one of those surge values and turn it to a hit. But I can only do that with 1. I can't do it. 1 surge token translates 1 dice from a surge to a hit. So think about the algorithm to handle surging based on these tokens, the presence of tokens. I don't know how many tokens I have, and I don't know how many die that the attacker rolled, but I have to have an algorithm that says I have an arbitrary number of dice and I have an arbitrary number of surge tokens. And of those dice, some of those are going to be surge values, some are not. And so how do I keep track of if I have 3 surge faces and only 2 surge tokens, that only turn 2 of those die from surges into hits, or if I'm on defense into blocks? That algorithm gets pretty complex. But if you walk through and build that algorithm, whether you're surging to defense or to offense, the algorithm is essentially identical. It's just, in the end, do I turn that surge into a hit or into a block? It's kind of a long algorithm. It's probably a 15-line algorithm. And if I get any bugs, it would be the same bug likely if it was offense or defense, because everything's the same other than what you turn to. And we see that in this handle surge, right? The only thing that's really different is this one if statement. So what we're doing is we're modeling our data, and the choices is do I put the surge function inside of the class like this, or do I put it outside of the class? That's a conscious choice that we make. Do I have the roll function inside the class or out of the class? That's a conscious choice that we make. Do I use 2 different classes, or do I try to pigeonhole these into one class? Another choice that we make. This is modeling, right? A core activity of programming is modeling, and how effectively you model is really difficult and determines the maintainability of your application when you're months down the road and you have to deal with these classes that model certain behaviors. And as they grow and you split them into multiple classes, the ease of which you can do that depends on how you started and the choices that you made. And sometimes you make the choice that seems like the right choice today, and 6 months down the road, it turns out, oh, that was a bad choice. Crap, I wish I'd made this 1 class and not 2. I thought I was going to need for sure 2 classes, but now I really wish I'd made it 1 class. But we will frequently get in this situation where I have 2 things that are different. And going back to the real world, right? I have 2 things that are different, but a lot of the time they're the same. They both get rolled. They both surge, which they turn from one color, one face to another. They have a lot of similarities to them. And I want my model to reflect that. And this is where an abstract type can be very handy, because I have 2 things that are different enough, but common enough that I want to do something with them. So I'm going to demonstrate here how to use an abstract class in order to combine these 2 things, so that I'm going to get rid of this handle surge, so that I have a common type to pass in and I can get all the IntelliSense, but they can operate differently down inside of my handle surge function. Okay. So I'm going to code that up, and I'm going to start by coming up here, and I'm going to create what's called an abstract class. I'm going to use TypeScript's abstract keyword and call this die. So this is the common class that the other 2 are going to be children of. So the die class, what does every die have in common? Well, it has a value, and that's a die value type. It has a color. That's a die color type. Right? And it does have a roll method. And for right now, the roll method is the same in both cases. So I'm going to do this Now, now that I've done this, I can take these offensive dice and this defensive die, and I can tell this, hey, I want you to be a specific kind of die. You're an offensive dice, you're a specific kind of die. So I use the extends keyword and give it the parent class. So this extends die, right? And at this point, I don't need a constructor anymore. I might put that back in. I actually don't even need the roll method or the value yet. So I don't need anything in this. I'm going to do the same thing with defensive die. And now I have these two die, and we're missing out our constructor to tell us what the color is. So let's go into the parent class and let's give it a constructor. All right. And we'll use the shorthand to do this. And notice I'm getting this error, right? Constructor implementation is missing. Okay. All right. We don't need to do anything inside of the constructor. We just set the color. So we can remove the color from there. And now we're passing in the color and they're already set. And now this works. Notice that this is working correctly. This now gives me the opportunity to get my IntelliSense. I do die dot and I see all the properties that a die has. It has a color, it has a value, and it has a roll method. So that's really cool. I get my IntelliSense and I can be explicit about this type, although TypeScript was able to figure it out because it was an array of die, so it knows that a specific one is a die, but I can be explicit about that. Now I've got my problem down here. And this was always kind of a problem, that I had this if statement inside of my handle surge. Well, because these two classes are separate classes, I could do something tricky like surge to value, right? And that's going to be, I'm going to set this equal to die value. For offense, they surge to hit all the time, right? And for defense, they surge to block. Okay, so now in my handle surge, rather than putting in this stupid if statements suck all the time. If statements are bad, the fewer if statements you have in your code, the better. So rather than a stupid if statement, I can just say die value equals die dot surge to value. Now this doesn't work. So I'm going to back up some of the changes that I've made. And I'm going to show you how this would work if we had two different classes. Okay. So let's put our constructor. I'm going to put all this code back in here and uncomment this. So we have a regular, and I'm going to get rid of the extends function here and put this code into my defensive die. All right. So now what I've got is these dice, they have their own surge to value. And if I just get rid of the types, if I make these like any, an array of any and any here, notice what happens is, and let's run this again, the result is correct, but I don't have my types anymore. I want my types, but I also want the class to have knowledge about itself and how it behaves. So let's once again reverse our changes, and I'm going to bring this abstract class die back in and leave the surge to value, but I can get rid of value and constructor and the roll function because those are the same, right? So get rid of that. And I need to do the extends die. So this goes where, and now it's back to working, right? I'll make this run again. Oops. Make this run again, and we got the hit and the block. That's correct. The offensive die is surging to a hit. The defensive die is surging to a block, but I don't have my types. Now, since we have the class, we can set this type. We know that they share the base type of die, and this is die, right? And so now here we get our IntelliSense. Die dot, we get our IntelliSense, but we don't see surge to value. And if we come in here and we know that this is of type die, right now we don't have any IntelliSense. So I do die dot, I get no IntelliSense because it's of type any. I explicitly cast it to any. So let's give this a die type, and now it's giving me an error because it doesn't know about surge to value. And so with an abstract type, what I can do is I can say, I'm going to go ahead and give you the surge to value. I'm going to push that up to the parent class and give it a type, but I won't set it. And instead, here I've basically done the same thing and explicitly set them inside of the subclass. So now notice my problem goes away, my error goes away. And if I do dot, I see color, role, and surge to value, because both of them, the offense die and the defense die, they have the surge to value, but they're different. And now I have greatly simplified this algorithm. This algorithm is completely the same for an offensive die or a defensive die. And the knowledge about what's unique about them sits inside of the die itself. I didn't push the knowledge about how to handle offensive die versus a defensive die outside of the class. I let that exist inside of the class. And now if I want to say, oh, my role function needs to be different. Again, we'll do rather than using like a random number generator, we'll just say, if it's offense, it always starts out with a surge. And if it's defensive, it always starts out with a block, right? So on our offense, we're going to have a role method. And we're going to set this dot value equal to surge. But for defense, we're going to have a role method. And for that one, this dot value is block. Well, let's do blank. All right. So now I have given them a specific implementation that's different than the parent's implementation. At that point, I can get rid of this, but now I'm going to get an error because the parent doesn't have a role method. So this is one more thing that you can do with an abstract class, is you can create an abstract method using the abstract keyword. And you do role, and the syntax for this is really weird. It's let's see, did that work? Okay, I think that worked. Okay, yeah, so that works. We just give it the signature, but we don't give it a body or anything. So an abstract function has a signature, but no implementation. Let's delete that. So notice this looks really weird. This is a function. It looks like I'm calling a function or invoking it, but instead what I'm doing, I'm saying on the abstract base class, you will have a role method. In fact, if I go into this child now and I delete the role method, I'm going to get an error. And it says, hey, you are a non-abstract class. You do not implement the inherited abstract member role. And it tells me you have to have a role method. Because on the parent, I said, you will have a role method. All children will have a role method. So it forces me to implement the role method. So this,
hey, Joe, we're almost out of time. Just a couple more minutes.
Yeah, thanks for the reminder. This is a concrete class, and this is an abstract class. And this is a great example of when to use an abstract class to have functionality inside that varies based on, you can have common functionality pushed into the abstract class and specific functionality baked into a child class. There's a lot of ways to skin this cat about having things that are similar. Interfaces are another way to do something like this. We're not going over that, but here's an example of how to use abstract classes and when to use them. I hope this helps, and maybe this will be a tool that you can use inside of your belt sometime in the future. And that's it. Thanks very much.
Thank you, Joe. That was fantastic. I know Chau over here is making hard eyes at you. Your code, at least. I was having a fun time following along on Stack Blitz. It's pretty fun. And I like that you took some of the pain of, hey, we've all been programming all day for our day jobs, and you're like, hey, here's this random dice game for Star Wars. We're going to talk about that now. So that was a really nice touch.
Well, it's nice to have an opportunity to actually practice it. You know, so often it can be hard to sit and listen and to have the opportunity to kind of practice and manipulate the code yourself. There's no better way to learn than by doing, right?
Mm-hmm. Exactly. Cool.
All right.
I'm
well,
excited to see channels.
We're going to get right into Chau Tran's. But first, I'd like to introduce Chau a little bit. So Chau works to bring the best engineering practices to web applications production. He is currently with Nrwl as a senior engineer. Previously, he was with Swimlane, a security automation and orchestration platform, and Architect Now, launching several successful projects. He's the creator of AutoMapper. You can find it on Twitter at AutoMapper, previously at nartc/AutoMapper for TypeScript. He also is the creator of ng-neat/tailwind for Angular and a core member of NestJS. Also, he is one of Angular Vietnam's founders. He blogs, live streams, and maintains open source projects. Chau is also an Angular developer expert, Google developer expert, GDE. And last but not least, he's a husband, a father, and a learner. Did I get everything?
Thank you. Oh, actually, there's just one more correction.
Okay.
I'm the creator of AutoMapper TypeScript.
Oh, gotcha.
Not the original AutoMapper. So
AutoMapper TypeScript. Still, we all use TypeScript here, so that's what we care about. Go ahead, Chau.
all right, so I think that's it. The introduction that's it. So okay, bye. The Joe's presentation is so good. I don't think I can present now. I'm just kidding. All right, I'm gonna share my screen.
Hard to follow.
Real quick here. All right, so before we get into this, I don't know how much time I'm gonna have, so I'm gonna be live coding, but I'm gonna be doing that in my editor because that's where I'm most efficient. But I'm gonna push the code to GitHub at the end of the presentation. And this slide I made before, like 1 minute before the meetup. So bear with me. All right. So today we are gonna learn about something about NgRx that you might not know about. So the title of the talk is "You Can Slice NgRx." Oh, by the way, if my screen is too small or too big, please let me know. I don't look at chat, so
I'll watch it for you.
Yeah, panelists, please assist me. Right, so my title of the talk is "You Can Slice NgRx." Right. And again, I'm Chau Tran. I'm senior engineer at Nrwl. My recent Angular GDE. So happy to be here. Thank you everyone for showing up. All right, just a moment of memory lane here. So this is a talk of Mike, Ryan, and Brandon from ng-conf, I think 2019, 2018. And you can probably hear Brandon saying boilerplate here. So I'm gonna have to, sorry, Brandon. And the goal of this talk is to take the reducing boilerplate, even though we all know that the things inside of NgRx is not actually boilerplate. But for some people, for some types of state, we kind of want to reduce that boilerplate a little bit more. Right. So this is the current state we have, not the current state, but like what people are familiar with NgRx. We have create action, create selector, and create reducer. Recently, there's a PR from Marco, a core member of NgRx, put in that is create feature, and that takes away the create selectors. You don't have to create selector anymore if you use the create feature. If I have time, I can talk a little bit about create feature at the end. But now today, we're going to take a look at create slice. Create slice is a community effort, not in the core code base of NgRx yet, but we're going to take a look about that. Right, so what is create slice? You imagine your state, your application state or global state is a cake, and each of the feature state is a slice of that cake. So the slice will have all the layers of basically state management. So you have action, reducer, selector inside of a single slice. So that's basically the idea of create slice. And the concept of create slice is from Redux Toolkit. So if you're not familiar with Redux Toolkit, it's very prominent in the React ecosystem. And the React Redux author, Mark, actually recommend Redux Toolkit now. Like it's in the official documentation of Redux or React Redux. So I kind of take this idea and I create lines for NgRx. So we're going to take a look at the demo. The agenda is we're going to start out with a simple counter with I will call it vanilla NgRx. Right. So then we're going to convert that over to slides so you can see that what the difference. If we have time, then I can get into entity. Right. So I'm just open up. Can you see my screen okay? Can you see my code okay? All right.
Looks good, but I'll watch the chat for you.
Yeah. If anybody in the chat want to zoom in a little bit more, please let me know. All right. So what I have here is just a simple Angular JSON, Angular CLI project that I created. Inside of here, I have two modules with two components, a counter and a to-do. And I have not set up anything except for I install and set up some NgRx. So this is what you're going to get when you run ng-add and NgRx store, ng-add NgRx store DevTools, and ng-add NgRx effects. So this is what you get. So now I'm going to start my application here, which I already started. So we go to localhost 4200, and this is my application. And you can see that we have, go to Redux. We have Redux set up for this application. And my state is empty because I don't have anything set up yet. Right, the first thing I want to do, I want to set up some route for this one real quick. So I'm going to go to my app module. All right, I'm going to go to this and say browse, and this is going to be a type of browse at full and redirect to. This one is a counter, right? And then I have a path of counter. And this is a load children. Import of dot counter. Oops. Counter module. Then m dot counter module. I'm going to just copy this and have that as a to-do. This is to-do module. So now I have my routes. I'm going to set up the router module here with for route and say routes. Right, now that's my route set up. I'm going to go back to app component. I'm just going to delete everything in here. I say h1 ng-conf. Oops, Angular Meetup, ng-rx, slice, quick, that. Let's do this. It's just a route a link. It's going to be to counter. Counter, and yes, let's put it into and down here just have a route outlet. So now back here, now I have my counter and to-do link, but I haven't set up the route for each of my modules. I'm gonna do that for the counter module first. All right, so this one is counter routes, add, and then the component of counter component. And just put in router module dot for child counter routes. Save. Now go back. We see that we have a counter, and inside the counter component, I kind of have this template of the counter, and basically two more counts. Say, hey, you have click incremented this many times, or you have click decremented this many times. Now, so we're gonna stop this with NgRx store. Very, I guess, very familiar. You're gonna have a store, and you're gonna have counter.action, right? .ts. You're gonna have counter.reducer.ts. What else? Selectors. And then you're gonna have. I'm gonna put in an effect as well, right? So now for action, we're gonna start with actions. We have const increment, which is create action. Right? And this is counter called increment. Right. And then I have decrement and decrement. I'm gonna put in two more. One is multiply by, and this is multiply by, and it's gonna be a action with a payload of multiplier. And it's gonna be a type number. Just gonna copy what inside there, put in here, and this one is the multiply by success. So you can kind of tell that the multiply by is because it's gonna run through the effect. So this is my action, and I'm gonna export like a namespace for like counter actions, right? And just gonna put these two guys in, the four guys inside here. Say course. Now next is the reducer, because now you're gonna need the interface of counter state, right? Value of number, increment count of number, and the decrement count of number. Next, we're going to have the initial state of the counter state, and I'm going to use WebStorm here to give me my value. And I want my value to start 1. Next, I'm going to have the reducer, right? It's const counter reducer. It's going to be equal to create reducer, as in the initial state, and you have a bunch of on. A case, this is what I call case reducer. Again, you have counter action, increment, state. This one just state, value, increment count, state of increment count plus 1, and value, state of value plus 1. I'm just going to copy this guy. It's going to give me that command. Then one last one, which is multiply by success, because we don't want to handle the case of multiply by. Like, there's nothing to change in the state for that one. But like after we multiply, we're going to get the value, and that is just the value back from the action. So this is our counter reducer. I'm just going to do one thing. This is counter feature key. Next, we're going to have the selector. So this is counter feature, create feature selector, and we're going to use the counter state for this one and pass in the counter feature key. So that's our feature selector, and we're going to have 3 selectors for value, increment count, and decrement count. Select value, and this is create selector with select counter features, and I have counter dot value. Just copy this 2 more times. Select increment count. This is increment count. And select decrement count, and this is decrement count. And I'm gonna, same as action, I'm gonna have a counter selectors namespace. And again, just gonna put everything inside. Now, basically, I have my counter store kind of fleshed out, and I want to add the effect real quick. Counter effect is an injectable constructor. I want the actions from the effect, right? The store from store, and I have a read only multiply by, and this is an effect. I want to listen for, what the hell? I want to listen for this.action.py, the action of multiply by, and then I want to grab the latest value, right, from my store, select counter selectors, select value, and I'm just going to switch map this over to a timer to simulate to simulate like an async operation. So now I have the multiplier and the current value. I'm just going to pipe and return an action. Multiplier success, and my value will be multiplier times the current value. So this is my effect. Multiplier. All right, just rename this to multiplier, unless we change it everywhere. Just name this to multiplier. So, should happy. Okay. Now I'm going to go back to my module, and I'm going to provide all of those. So store module for feature, you got the kind of feature key and kind of reducer. Next, we have the effects module for feature, and there's an account effects. Right. So now that has been provided, so now I can use that inside of my component. So here I have a private store. I'm going to have a read-only of value, store, select, selectors, select value. And then I have increment count. See, select increment count, decrement count, select decrement count. And now I can just use this with value, sync, increment count, async, and decrement count. Async. Next, on decrement, I will dispatch an action, counter action, not decrement. Just copy that. Increment. Save. So my two buttons is going to call on decrement and on decrement, and when those events are handled, we're going to dispatch the appropriate actions. And so now I'm going to go back to the app. Now you can see that my count now starts with 1, and that's exactly what my default value is. So I'm just going to start increment, next can start decrement. And of course, I can just jump back and forth, right? Great. And this is probably not what you're here for. And you can see that how much code we have written to just implement that simple counter. And by the way, Eric, I mean, I see the chat of bubbles. So if it's any questions or ask me to slow down or whatever, please let me know, because I'm not reading those.
I'll let you know. So far, we're just complimenting your speed at using your IDE with your multiple cursors and your hotkeys.
I will have a series on that later on YouTube.
Perfect.
Okay, so now we have, a working counter example, but look at how much code we have. We have an action file with these, with these many lines, a reducer with these many lines, and the selectors with these many lines. And you're probably gonna have somewhat some simple state or feature state in your applications that kind of model this. It's very straightforward. You have some actions, you have some selectors, and you have reducer. Very straightforward, but you want them to be global, so you actually have to turn to NgRx for that, right? How can we fix this? I'm going to introduce Slice now, and by that I'm going to have to open my terminal, and I'm going to add some libraries again, because Slice is not in the core NgRx yet, so we have to add some library. The first thing is NgRx Slice, and next is NgRx Immer, and the last one is Immer. So while that's going, Immer is a library that allows you to update state immutably in a mutable way. I'm going to explain that when I get to Slice. So now I have those three installed. I'm going to create a file called counter.slice.ts. Right. I'm going to borrow the state and the interface and the initial state from my reducer. I'm going to put that in here for my slice. Next, I'm going to export a const, and I'll call this create slice. Right, create slice accept a configuration object with 3 required arguments or properties. The first one is the name of the slice. So this is my counter slice. Next is the initial state, which I name it correctly. So I'm going to use the shorthand syntax. The third and the last one is reducers. So now reducers is a dictionary or a record. So this is a record of like string and then something. And then something. So you can think of the reducers is, so when increment happen, right? When increment happen, what do you want to happen, right? So when increment happen, I want to increment my value, my count value, and also increment the increment count. So this is where immer comes into play. With NgRx, you're gonna have to like return a new object and then you change what you change. But with NgRx slice, you can just mutate it. And this is thanks to immer. Same thing with decrement. I'm just gonna copy this one. I'm gonna change that to decrement count. And this is actually minus, right? I think I have a bug in here, but it doesn't really matter now. So go back here. So for decrement, I'm going to decrement the value, but I increment the count of the decrement button. But now that's increment and decrement. What about multiply by? So you can see that multiply by is what I call an async action, because you dispatch like a trigger, and then that trigger is going to handle in the effect, and you dispatch like a success or failure, right? So for that case, in NgRx slice, you can pass in an object, and inside of this object, you're gonna specify the cases for this multiply by. So right now I have the success and the trigger. So for success of multiply by, I'm gonna have a state and action. My action is gonna be the payload action, and it is the value of number, right? If you haven't noticed, this is actually the same as the type that you give to the props. So when you work with slice and you have an action with the payload, this is how you would like type that payload action. So now my action can have that's value of type number. So this is just value equals value. And then I have a trigger. And then trigger is a little bit tricky here because trigger doesn't really change anything in my state. So basically I can just have that. But that seems silly. So the from ngRx slice, I expose a method called no-op reducer. And then you can just give that to trigger. So basically, it is not going to change anything in your state. It just acts as an action. Right, so that's it. This is my slice, right? I list all the things that might happen and might update my state inside of my slice. So what this create slice return? It returns an object with name, actions, reducer, and selectors. So it returns the actions and the selectors as well. So now for the actions, I'm gonna rename this as counter action. For selectors, I'm gonna rename this as counter selectors. And for name and reducer, I'm gonna spread that to a counter feature. So now I have counter feature, counter action, and counter selectors. Let's go back to the counter module, right? Now we're going to change out the reducer for the store. Instead of passing the counter feature key and the counter reducer, you can just actually pass in the feature, right? So if you don't know, for feature actually has some overload. You can pass in the feature name and the reducer, or you can pass in the slice, which is an object with name and reducer. So this is added for the create feature of NgRx, and it works for the slice as well. So that the counter effect stays the same. In fact, we're going to go to the counter effects, and we're going to use the actions from the slice and the selectors from the slice as well. And you can see that the multiply by all of a sudden screaming, because multiply by is not an action. It's just an object with trigger action. And we don't have any multiply by success. We're going to have multiply by and the success. Right? So that counter slice. Now back to my component. Right. Again, I'm just going to replace the selectors from slice and the actions from slice, and it's save. Right. So now I don't think I have any more reference from selectors, reducer, or actions in my code. So let's test if it's still working. Probably not. So something wrong here. Let me pull up this console. All right, I need to restart because I asked something. Yep, ngcc. So let's that run. Back to this, refresh. Yay. Right, so our application is back, and our state, you can see that this is the state from the counter feature. It's no longer counter feature key and counter reducer, it's just counter feature, right? And now if I increment and I decrement, it works correctly. And you can see that I have the action inside of my Redux DevTools as well. Of course, I can time travel. Right. So now we're going to go back to the code, and let's take a look at the counter action and the counter selectors. I'm just going to scroll down a little bit. So for counter action, I'm just going to add a little bit more of space here. So right here. So for counter action, you can see that it generates the actions for you, like the slice generates the action for you from the reducer. And so for increment, for the increment case in the reducer, it will generate an increment action. Same thing with decrement. What about multiply by? So multiply by is an object, so it's going to generate a trigger and a success for you. And the cool thing about this is it's using TypeScript to make sure that you have intelligence. So let's say this is a function, but you cannot call it. You have to pass in the value, right? Because this is what we specify here. And if it changes to like foo, right, it's going to scream at me because I need that value foo. So the type is covered by TypeScript. I cannot see it because the camera. Okay, so there we go. What about counter selectors? For selectors, it's going to give you the counter state, which is the feature selector, and then everything for each of the state or property inside of your inertial state is going to give you that selector out of the box. So now if I add something to my here, this is foo, a string, right? And I add foo string here in my initial state. Now my counter selector is going to have the select foo as a memory selector of string. So I have, again, TypeScript covers all my type for the counter selectors and counter actions. I'm going to remove the foo string and remove this one. What's screaming? Oh, fine. Save. Now go back to selectors. You can see the counter selectors inside of the counter selectors file is no longer used, so I can just delete that. All of these no longer used, so I can just delete that. This one's no longer used, can just delete that. Now I can just delete this file. So that's selectors. Next, reducer. You can see that not used. It's grayed out, so it's not used. Same thing with the reducer. So it's just going to delete that. Same thing here. And same thing here. And just delete that reducer. And then the action, just delete everything inside of the action. Just delete that. Now that
Brandon's
is
going to be mad at you, Chau.
ngRx slice. So now everything is inside of this one file. Again, for simple state, for simple feature state, you can use slice for simple boilerplates. And again, here I don't have that multiply by, but I mean you get the gist because we have the effect here. ngRx slice does not mess with how you write your effect. Basically, it just gives you that actions, selectors, and reducer. So you don't have to write those because you're already writing them when you think about reducers. So again, it's working. I don't think I have enough time for it to do editing.
That was fantastic. Good job.
Any
Chau.
questions so far?
If you guys have questions, you can throw them in the Q&A or the chat. I'm watching both.
I'm gonna stop sharing.
I have a question for you, Chau, just to get everybody's question flowing. I bet you get asked this a lot, so don't hate me.
That's all right.
Why this versus component store?
No, hold on. This is global store, right? This is global store. I use this.
Oh, I see. For global store, because then you still have effects and actions.
I use this. Right.
Yeah.
I use this for global store. I still have component store.
Okay, gotcha.
Yeah.
So if anyone's familiar, component store is great because you still have like most of the stuff in one file, but you don't have actions and effects to deal with. It's very different and very simplified. Well, this still lets you have those actions and control your effects how you want to.
Yeah. Actually, let me reshare my screen because I did not introduce enough. I mean, all of it. So you can see that the action, right? The action get dispatched. Where does this name like come from, right? Because we did not do create action and we don't give them a type. So where does this action type come from? It's actually come from here, the name that you give to your slice and the string of the method. Right, so this is basically I have a function under the hood. It's gonna like capitalize this one to counter. If you have like counter slice here, right? Counter slice, it's gonna be counter slice, just like that. Right? Or maybe you have counter page. So this slice just for the page itself, or then counter API for the API itself. So you can have that. Then it will take that, we'll take this one and this property key and combine those. You can actually customize it with a slice action name getter. So this one, you can have feature name and action name. You can return, maybe you don't like the square bracket. So you have that, and then you have feature name, right? And then the action name, maybe you like some fire. So I can do some fire. There we go. And save. So now my slice action name getter will return that. If I increment, you see that it's actually the action type. So this type will propagate through the actions and reducer, so it gets handled correctly. So you can have this as well. Last one is extra reducer. I'm gonna bring this up here a little bit here. So extra reducer. So what is extra reducer? The actions, the slice generates the actions from your reducer. But sometimes you will have actions that outside of the slice that can update this state. So maybe I have some like cost double, right? And this is like from external action. I call this like external, and this is double. Right? So now you have this double action somewhere, but you still want to handle this inside of this store or this slice. How would you do that? Inside of extra reducer, you can just put in a bunch of on, and you can handle that double state Of course, you have state and the value of state dot values times 2. Of course, you're going to have some typing error. This is something I haven't know how to do yet. Type of double, I think, yeah. So for on, you're going to have to do that. And because you have ngRx immer, you can actually have import immer on from ngRx immer. And if you want to use this one, you don't have to do the spread syntax. I'm just going to do this here real quick here. So double again state, and you can just do state dot value time equals 2, I think. And then of course you're going to have to do this as well, because the type. So you can do this either way. But this is actual reducer, and I know NgRx, like core team, they recommend people to treat actions as events. So you might have events, external events that can change the state of this slice. So that's actual reducers, and I think that's pretty much it. And let me just touch on it real quick. I was gonna do like entity adapter, right? Entity, so that you have the adapter. But the one thing different from this one, from this compared to the ngRx entity, is that it has immer. So it has immer. I cannot give this type, but again, it's exactly how you would use create entity adapter. But one of the cool thing is that you can now, instead of, let's say I want to add a to-do, you have an action called add one, and you can do to-do adapter dot add one, and you can just pass the entity method directly to an action, so you don't have to do any additional typing. So that's entity, and I really want to get into entity, but I don't think I have enough time to live code it.
So it's like NgRx global store shorthand. I love this.
pretty much. But again, be cautious of how and when you use it, because a lot of people are very meticulous about their action type. Right? Yeah. This takes that over.
I have so many questions for you, but I know we're out of time, so I can keep going all night though.
My Twitter is open, or you can have me back another time just for questions.
Yeah, you're definitely welcome, man.